So what I'm going to talk about today is bonding, chemical bonding. And um, there are two principal types of chemical bonds. The first one is a bond that forms between a metal and a nonmetal. And if you remember metals and nonmetals, those were the two big categories that I broke the periodic table up into. And when a metal and a nonmetal combine to form a compound, it's called an ionic bond. And an ionic bond involves the transfer of electrons. Okay? Now, the other type of bond that we're going to be studying occurs between two or more nonmetals. So a nonmetal plus another nonmetal. And that particular type of bond is called a covalent. And instead of happening because there's a transfer of electrons, in a covalent bond, there's a sharing of electrons. So if nothing else, you figured out that bonds between atoms take place because of something that the electrons do. Now when you form a ionic bond, I'm going to talk about that one first, but the rationale for both of these, the reason why bonds form, is for the same reason, and I'll explain that. What happens is, when atoms combine to form compounds, the elements are trying to form what's called a stable octet. And what a stable octet is a full S and P sublevel. And if you remember what an S and P sublevel looked like, okay, an S was one orbital with 2 electrons possible. A P was 3 orbitals with 1, 2, 3, 4, 5, 6 possible electrons. So if I add those up, 2 plus 6, I get 8, and that's what is meant by octet. And another name for a stable octet is a noble gas configuration, electronic configuration. So, okay, the rationale or the reason that bonds form, regardless whether it's an ionic or covalent, is that they're doing so in order to fill up their S and P sublevels. All right? So, I'll go to the next one. I want to talk about an ionic compound that forms when sodium and chlorine combine. Now, sodium is a metal, chlorine is a nonmetal, so it's going to be an ionic bond. So, first take a look at sodium. Its electron configuration is 1s2, 2s2, 2p6, 3s1. In terms of what an orbital diagram would look like, I'll start at the 2s level. I'd have that. The p's would be all filled in, 1, 2, 3, 4, 5, 6, and then I would have a lone electron in the 3s sublevel. Now if I draw chlorine, Cl, its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. And its last orbitals would look something like this. The s, there'd be one electron there, one electron there, so paired up electrons. The p would have 1, 2, 3, 4, 5, and I'm going to draw that down just to kind of show you what's going to happen. 5 electrons. Now, what's going to happen is this electron right here is going to move down and be placed into chlorine's P sublevel. It's going to do that because when sodium loses an electron, it now has a full S and P sublevel. So that's full. And when chlorine pulls away an electron from a sodium, it also gets a full S and P sublevel. All right? So they're both full. So they got what they kind of wanted to have happen. When the sodium lost an electron, it became a sodium ion. When the chlorine gained an electron, it became a chloride ion. Sodium ion is called a cation ion, and a chlorine ion is called an anion. Okay? So ionic compounds are formed from ions. And if I were to look at what this ionic compound would be like, there would be a sodium ion next to a larger chlorine ion. They'd be electrostatically connected, combined, just like a set of magnets. Okay, so that's an ionic compound. Now covalent. And the covalent compound I'm going to draw is a chlorine molecule. So going back to what chlorine was, it had a electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. And to draw that out, I'd have 2 electrons there. In the p, I'd have 1, 2, 3, 4, 5, like that. If I drew another chlorine, being 1s2, 2s2, 2p6, 3s2, 3p5, okay, it would have the s filled, would go to the p with 1, 2, 3, 4, and I'll put that one down. So now what's going to happen in a covalent bond, because chlorine is a nonmetal bonding to another nonmetal, is, again, they're trying to get a full S and P. But it's not practical for one of the chlorines to lose all of its S and P electrons. Plus, there's no place for the other chlorine to take those. But what they can do is they end up sharing that last orbital. And in sharing, it gives them both 8 electrons in their S and P. So that's how a covalent bond occurs. If I were to draw this, I would represent it with the symbol chlorine, 2 electrons between it, showing the bond that formed, sharing bond. Another way that is probably more commonly drawn to represent a chlorine molecule is a dashed line. But that dashed line signifies the sharing of the electrons in one of those orbitals, giving each chlorine an octet. If I could kind of look at what this molecule would look like, there would be a positive proton from one nucleus from one chlorine, another one from another, and then